All right, we had 2 problems left. Number 12. Notice the big difference, gentlemen. Set up, please.
Pay attention to the notes, guys. Time to lock it back in.
Notice the big difference here. We have a cube root now instead of a square root. The problems are going to be done pretty much the same way with this one pretty big difference. When you see a cube root, that means we will make groups of 3. Otherwise, the work is going to be the same. But make sure you notice a small detail. If you don't, it's going to affect the whole problem. Let's start by breaking down the number 8. Just like perfect squares, we do have perfect cubes. You guys have very little, if pretty much probably no experience with perfect cubes period. So most of you wouldn't know just by looking. 8 actually is a perfect cube, so we are just going to go ahead and break it down. But this one is easily memorized. Yes, it's 2. Good. So breaking it down, our only options are 2 and 4. And 4, of course, we broke it down again into 2 and 2. Broken down the 4, so I'm done with it. And again, we're wanting groups of 3. We have 3 2's here. And nothing else left, so a full 2 can come out of here. And it's equal to 2. So far I've got 2. And then I need to break down a to the 6th and b to the 9th. A to the 6th, again, this is a cube root. As we discussed yesterday, you can either write out a 6 times and make your circles, or you can write this with the fractional exponent and solve it that way. That's how I'm going to do it. That's a bit quicker here. 6 over 3, in over out. And when we divide, it's just a squared. A squared will go in our answer. And let's repeat that for b to the 9th. Once again, this is a cube root. And 9 divides nicely, so I'll use the fraction again. 9 over 3. And dividing, we get b cubed. I have run out of things to break down, so all I have left to do is just write this as one answer together. 2a squared b cubed. And there you have it. Questions over number 12. Bless you. You're welcome. Number 13, same idea, but it's definitely a bit more complicated than number 12. First off, I hope you notice that negative in the front. Don't do where you make these plus plus because you got 2 negatives in a row. That will end up, the answer will end up positive overall, but not for that reason, so don't make that mistake. So put a 1 there, so it's like a negative 1. Give it a number. We have negative 1. That needs to carry over into our answer. Again, notice that we have a cube root here. Let's first break down the 64, negative 64. You may or may not remember, but negatives under a square root with a 2 are not allowed. They are allowed with cube roots. If you don't quite see why that is, I'll show you that after I've solved this part of the problem. So just hold off there. But when you take the cube root of a negative, your answer will also be negative. That's a guarantee. So first thing I want you to do is go and just take that negative out and put it outside of the root in your answer. That way you don't have to worry about it later. Next, we'll break down the 64. 64, two easy numbers, 8 and 8. Reminder, this is a cube root, so I'm not going to circle these two 8s and say I'm done because I don't have 3 of them, I only have 2. So we'll continue breaking down the 8s. Both of those break down into 2 and 4. And then the 4s can be broken down some more. And the 4s are gone because I broke those down. And so are the 8s. All that I have left are 2 groups of 3 2s, 6 2s. So I can make nice groups with all of them. Group of 3 2s here and a group of 3 2s here. So I have a 2 come out of this group and a 2 come out of this group. That's going to give me 2 times 2, nothing left over. 64 is also a perfect cube. And multiplying, that's just going to give us negative 4. Again, I'm going to take a moment and explain why a negative is allowed here. Those of you who don't quite see it. And just because of space, I'm going to do that on a post-it note, and then I'll take it away when I'm done. So, when I take a cube root, that means that the number I end up with, if I multiply it 3 times, I'm going to get negative 64 here. So I have negative 4 times negative 4 times negative 4. And if I multiply these 3 numbers together, 2 negatives make a positive, but when I have a third negative, it turns it back into a negative. So an odd number of negatives multiplied together will still give you a negative answer. And then I multiply 4 by itself 3 times. 4 times 4 is 16, times 4 is 64. So that's why that negative is allowed to be under the cube root. But as we discussed before, it's not allowed under a square root because it's not possible. Any questions on that concept? Okay. Next, the letters. We have a to the 11th. Once again, cube root of a to the 11th. In this problem, I'm going to solve A one way and B a different way, just to kind of give you options for those of you who want a different method besides just writing out the letter however many times. So A to the 11th, I'm going to do the normal way. Write it out 11 times, 11 A's. Got 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll make our groups of 3. And I have 2 extra. This method, like I said before, always nice. It's very easy to use, works every time. It's just a little tedious. So if you like it, use it. If you don't like it, I'll show you a different way in just a moment. This means we could take 3 A's out, and 2 can't come out. So those 2 stay back in the root, the radical. They can't leave it. So writing that out as an answer, we have 3 out. That means a cubed on the outside. And then under that cube root, we have 2 a's left, so a squared. That's the proper way to write it. I'll add that to my answer area over here. A cubed, cube root of a squared. and then I have to break down the b's. We have b to the 16th, cube root, (16b's) might be the limit for some people. Again, if you want to write out 16b's and make your circles, be my guest. That works. But for those of you who want a more straightforward way to the answer, I hope you've realized up to this point that every time I'm doing this process of making my groups, I'm just doing division. That's it. So let's do division. I'm going to turn it into the fractional exponent. Remember, it's in over out, 16 over 3. Which I normally do if I can, but 16 over 3 is not nice. It's going to be a decimal. To do this, what I'm about to show you, don't put it in the calculator. A decimal will not help you. Instead, we're actually going to do long division on the paper, but it's going to be very short. Quick little refresher here. 16 divided by 3. How many times does 3 go into 16? 5. Good. What'd you say?
You said three goes into 16 5 times?
Mm-hmm.
Oh, okay. I thought you meant like 3 times. Yeah. 5 is 16.
No. Yep. Goes into it 5 times, giving us 15. Subtracting, we're left with 1. 15 remainder 1. So this answer here is what we want. So I end up with 5R1, which we can, in a way, translate 5 out, 1 in. It's the same lingo I've been using. It just looks a little different. If I wrote out 16b's and did my circle, this is what I would end up with. 5 circles and then an extra b. And if I write that out, that's going to be 5 b's on the outside, so b to the 5th. And then inside the cube root, we have 1 more b, so just b. And this gets added to my answer up top. Two methods, both correct, both valid, your choice. Whatever you want to use on homework, quizzes, tests, up to you. Just make sure you get the right answer. Questions on the second method? Okay. Lastly, we just need to put this together into a very nice answer. Setting it up, I'm going to put my radical at the end. Cube root. Don't forget that cube there. I will have students who write everything out correctly on the test and then they forget that cube root. You do lose some credit for that. That is a big difference to leave that out. Starting outside, we're going to go with the numbers. -1 times -4 turns out a +4. Check these off as I go. Next, the letters in alphabetical order. A cubed, b to the 5th. All that's left is the stuff under the radical. Again, alphabetical order here. A squared b. Make sure everything is put into the answer that you have written down. Don't leave anything behind. And then we're done.